Hello, everyone, and welcome to yet another edition of Green Guardians, an initiative of India Business and Trade. My name is Archana, and we have with us today Mr. Kumar M. He is the Chief Technical Officer of Armax India and Director of Smart Grid Analytics India Limited. So thank you so much for joining us today. And I know you have been in the industry of smart grids of energy sector for a very long time. So, if you can just tell our audience a little bit about you and about the company.
Sure. Thank you, Archana. Nice meeting you, and thank you for your wonderful introduction. So myself, I am Kumar M. Basically started Armax 18 years back. And since 2009, the advent of renewable energy in India, we have been working closely with many IPPs and EPCs to ensure that we give a renewable energy solution. And through this phase of the experience which we have gained, we've also started Smart Grid Analytics Pvt Limited a year back. But despite being a young company, we have garnered almost around 4 gigawatt of portfolio in India and abroad. So we're doing a big chunk of projects in abroad as well, where it has multiple SaaS products. Right. So I think, yeah, that's a brief introduction. We'll go further and we'll talk about it.
Because renewable energy, a more efficient form of energy delivery is the focus of the present government, of the present decade also. So, your company is working on SCADA system, which is supervisory control and data acquisition, and which are essential for gathering and analyzing data, for monitoring and controlling of different kind of renewable energy sources, which is either solar, wind, or any other renewable form that might be there. So how does this impact, SCADA system impact the regulation and safety aspects of the electricity grid or the grid system in itself?
So basically, SCADA, if you look at it, these are pretty old technologies. SCADA stands for supervisory control and data acquisition. So wherein these softwares were actually built for a process industry like steel, cement, sponge iron, and other industries. But with the advent of renewables, that is solar, wind, and battery energy storage systems, what is happening is the controlling portion is actually very less compared to the data acquisition. There is humongous data which has to be acquired from the field, and then an intelligent decision has to be made out of it. So the grid controlling features, yes, there are products like PPC, EMS, which I will also touch upon. So the maturity of SCADA has not been that wide as how it has to be. The reason is conventional systems were made for, as I mentioned, process industries. And the SCADA systems which are being used right now for renewable energies are not capable for extensive data logging, which is meant for 25 years. Because if you take any asset, it's an asset, and the more data points you have, the value of the asset grows into a tangible one. So to counter that, what we have done, we have also come out with our own product called One SCADA, wherein it is built on entirely mean language. So what it does is it uses big database, unlike conventional SCADA. So when you have big database, you can actually do elastic search. You can actually store a lot of information, pick it up. And then the way it helps is, grid integration. You can seamlessly integrate to the grid, transfer data on multiple protocols. It could be IEC 104, IEC 61850. And then also for the grid regulatory, like the CEA has come out with a grid code compliance, wherein PPC would be a part of it, that is power plant controller. Unlike thermal and other industries, they have AVR and AGC, that is automatic voltage regulator and automatic generator controller, which are standard, approved, and have been in the system for hundreds of years. Now, PPC is quite new because the more and more renewables are going to get into the grid short circuit ratio comes down. The moment it comes down, the instability of the grid increases more. The chances of grid tripping because of plant underperforming or not reacting to the grid side parameters is quite substantial. So to encounter that, PPC is a product which has to be used and which complies with the CEA statutory requirements of active power, reactive power, power factor, voltage control. So this also can be integrated into the new age SCADA, wherein the set points for individual grid code, we have done for 8 country grid codes, and almost all the grid codes remain same, just the bands and the controlling factors differ. And that can be easily entered from the SCADA, and the safety of the grid also can be ensured with the help of, 1 second resolution data logging in case of any events that can be backtracked, and the exact source of the root cause can be found out. This all can be possible through SCADA. Yeah.
Right. So it seems like it's an integral, tool to make grid smart grid system more efficient. But as you mentioned that, smart grid concept, SCADA, they have existed for a very long time. It's not something which is new, although it has become, recently in the limelight. So has it, really been implemented in a very efficient manner? Has the technology matured? Has the adoption to smart grid matured? And where does India stand in terms of implementation of smart grid?
Okay, that's a very nice question, Archana. So I would like to bring forth a couple of interesting points. So when I mentioned earlier the power plant controller, they were existing in the other country grid codes in the year 2014-15. Because when we came out with the product of PPC, India was implementing it in 2020, where the other countries have actually implemented it in 2014 and 2015. And that's how we have gained knowledge for other country grid codes and have implemented it. So that is one factor. And another factor is in India, there are multiple departments scattered. So one department is responsible for grid safety, one department is responsible for trading, one department is responsible for the policies. Now, actually, we are seeing a lot of transition. Earlier, POSOCO has been renamed as Grid Controller of India now, and all the rural load dispatch centers, that is, we have Western Rural Load Dispatch Center, Southern Rural Load Dispatch Center, Northern Rural Load Dispatch Center. So the entire load dispatch centers have been brought under Grid Controller. So all the team members are now having the single agenda of ensuring grid code safety. So it's a very good move by the Indian authorities, and we are picking up, and I'm sure we will pick up very soon. Compared to global implementation, yes, the smart grid concepts have been implemented by Europe, Latin America, and parts of East Asia a long time back. But we are catching up very soon. We are there right now with a good resilient network. And in terms of maturity, I could say that our government and our team, the Indian team who is framing the agreements, are actually pretty good in catching up, and we are at a very, I would say, progressive scale compared with respect to test procedures, implementation, checking of the systems online. So yeah, India is catching up at a good pace.
Right, sir. Right, sir. And India's industrial activities, its consumption at the household level of electricity, it has magnified in the past decades. So, smart grid technology in this age, in this period of time, why is it a need of the hour? Because India does face electricity crisis, even if it's the tier one cities or maybe if it's in the rural areas. So why do we need it at this point where the industrial acceleration is also at its peak?
Yeah, so the reason we need is, as I mentioned, there are multiple departments which are responsible for different aspects of the grid. So one department is responsible for the grid safety. One department is responsible for the forecasting of next day ahead consumption and trading. So unless until all the departments are merged together under single one roof umbrella, the data clarity, the data transparency, the aim of achieving the goal with a less error percentage doesn't get resolved. So that's what we are also trying to do. We are working with a couple of government agencies where we are trying to tell them that instead of having multiple agencies acquire data, third person predicting or forecasting, and then you using it, the error percentages are very high and dependency goes low. So we can actually accumulate it and make it like, the Aadhaar system, which has been brought for the Indian market, wherein everybody's IT PAN number is linked, Aadhaar number is linked, and there is no loopholes where somebody can escape the system.
Right, right. Just to get a perspective, so in case there is the traditional system of electricity delivery and versus the smart grid delivery. So what is drop in percentage of electricity disruption? So if you can give us a vague idea on it.
So yeah, I'll answer to that. Actually, I still haven't finished the earlier answer. Since you
Right,
asked
right,
the
right.
question, I got reminded of it. So
Right.
the advantages of using smart grid is, see, when we are able to forecast tomorrow's prediction with accuracy, and the same operator has knowledge of how much tomorrow is required and how much he is able to generate, and what is the dependability of the plants which are connected to the grid. Let us say you give a 5-star rating, 5-star are for dependable plants, 4-star are for semi-dependable, 3-star are for undependable plants. The exact accuracy at which you will be able to generate tomorrow's power versus tomorrow's consumption with the pattern of what day it is, what time of the year it is, whether it's a seasonal influence, whether it's going to be a holiday. These all factors play in a crucial role in trying to understand the forecast for demand and forecast for supply. And incidentally, Armax was one of the model. Armax stands for auto-regressive moving average exogenous model.
Okay.
So yeah, in 2001, when I did my master's in Karlstad University, Sweden, the thesis of my master's was understanding the power forecasting for a city called Christineham for day ahead and long-term forecasting. That is how the city is going to consume the load based on which day of the year, based on the ambient temperatures, based on the holidays. So based on that, actually power used to be traded in Sweden back in 2001. Now we are going to do that here very soon.
Right.
Right.
So, sir,
So
moving
the
on.
percentage, sorry, I'll come back to your question.
No problem.
The percentage of error, I would say, conventionally, we are not doing it in a single umbrella. So the error percentage could be between 7 to 10%. And if you actually do it in one single umbrella, the error percentage could come down to 2 to 3%. And when we say substantial amount of 5 to 6% could be lakhs of units saved, which can actually be sold in the market or can be stored in the battery energy storage systems, can be used for reactive power compensation when there is a abnormality in the grid.
Right. So moving on to the next question, why I asked the drop in percentages, because we are still largely dependent upon the traditional method of energy consumption, which is coal. But we have made some progress in terms of wind energy and solar energy implementation. So, how do we connect the renewable energy, the new energy, with the smart grid technology to make it more efficient, to leave lesser carbon footprints?
So I think in this particular aspect, India is actually doing much better than all other countries. But I think the way our Honorable Prime Minister is, declaring the agenda and the way forward of introducing green hydrogen. So green hydrogen could be produced off grid. I mean, you don't have to connect to the grid to draw power, but rather use solar energy, produce green hydrogen, and green hydrogen becomes a clean fuel for the automobiles as well. So like this initiative, even the smart grid comes into picture. So right now, as I mentioned earlier, multiple departments are handling multiple activities. So when we say smart grid, it is unifying all the electricity departments under one single umbrella, so that from the point where power is produced, we are able to measure what the plant is producing, and from the point where multiple pooling substations are connected, where multiple plants are pumping there, that also has to be digitized, wherein we will know what is the pooling substations performance, whether it is injecting reactive power, absorbing reactive power, does it need a compensation, and then from individual pooling substations to grid substation, wherein all the power gets accumulated. That also has to be digitized, and then the smart grid concept works in reality. That is the entire data of electricity flowing from one part, which is hundreds of kilometers, to the point of evacuation, wherein it can be traded or distributed to multiple states. So
Right.
that soon is going to be a reality. I mean, people are working towards it, and we are also trying to educate and bring this technology to them, telling that this is how it's going to help the grid stability.
Right. So moving from the industry perspective to the business aspect. So Armax, as you mentioned earlier, Armax has done 8 projects in 8 different countries. So,
Yes.
if you can reflect your experience on, setting up projects in different countries, whether it's the grid regulation, whether it's the implementation. So if you can, make a comparison perhaps of how the experience has been in these nations versus maybe India.
So, yeah, very, very good question. Very I would say troublesome question for me though, but
Okay.
so the grid regulatories across the world are actually many of the, I would say, advanced countries like Jordan. We have done in Jordan, Oman, and Vietnam, Chile. So all these places, they have the grid regulators have everything in place. That is how you set up to the grid, how you connect to the grid, what are the testing procedures, and unless until it is tested, you don't get permission to inject into the grid the power.
Right.
So this ensures that everybody is compliant to the grid code, and at the same time, the grid safety is also taken care. In India, earlier in 2020, when our grid code was implemented, it wasn't at that stage. But right now, at we are in 2023,
Mm-hmm.
right? In 3 years transition, we have learned a lot, and Indian authorities have been very stricter in ensuring that all the compliances, including the testing procedures, are adhered to, and then only they get permission to charge. So, so I would say it's a big quantum leap of step, because what the other countries have achieved over 6, 7 years, our officials teams with together strength effort, they have achieved in 3 years. That's actually a tremendous feat.
Right.
And wherein we're also advising some of key people on how to compare the grid codes, because the toughest grid code in the world, I would say, is Australia. So
Mm-hmm.
they actually do simulation studies first, and then they give approval, and then only that material can be procured and then placed in the site. So that's how they go.
Right.
And yeah, and the second grid code which was tough for us was the Jordanian grid code.
Mm-hmm.
So we did 2 projects there, and the Jordanian grid code also, the same similar concepts are also being implemented in India now. So that's a good thing to see.
Right, right. Because you mentioned that it's with the grid system, everything is coming into under a single umbrella, but then still the compliances, the regulations are quite bifurcated, department wise, and then state government, central government, which can be a deterrent factor if a company has to choose to go sustainable. So, you say that Australia has the most strict and stringent regulation. So is there
Correct.
something that India can adopt from those compliances, from the Australian compliances?
Yeah, actually, India is also adapting. I would say that earlier, when in 2020, the Indian authorities were trying to simulate with software and see how the grid is responding to the plants which are getting connected. Now we have moved quantum steps further. They're doing the transition studies. Then they're also putting in lots of working committees, like CA has put in a recent working committee, which they have come out with a proper and better grid code, implementation, so that there was little unclarity between read the space lines, something where everyone can understand their own version and perspective, which used to create loopholes.
Right.
Now all the loopholes are closed, and yes, they're at a pretty much good place, where we didn't have a testing procedure in 2020.
Right.
Now we have a stringent testing procedure on how to actually test before you connect to the grid. So yes, I think in a year or so we would surpass Australia as per their testing procedures, is what I would look forward to see.
Right, 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 sir. So, coming to the operation aspects of the company. So, you said that you have been with the company like 18 years, so close to two
Yes.
decades. So, what kind of projects are you receiving now? Because now everyone wants to go green. So, what kind of projects you're planning to undertake or you've already undertaken? Are there any goals set, for taking the technology to different parts of the country or to different parts of the world itself?
Yeah. So, to be frank enough, my experience when we started Armax until now is tremendous. The reason what I see is there are multiple players in the market who does bits and pieces of the software. See, somebody does SCADA, somebody does CMS, somebody does CMMS. So basically, CMS is central monitoring solutions. Let us say you have multiple plants situated in a global place. So sitting at one knock center, common center, you will be able to analyze all the plants, their performance, how much it is being produced. And then CMMS is digital work order optimization, wherein any equipment fails, automatically an alert is sent, a job card is created, the alert technician is alerted, and he fixes it so that the downtime in the revenue is very less. And imagining, being an owner, if you have 100 plants, managing 100 different managers and 100 different managers managing 400 different technicians who are situated under them directly becomes a Herculean task. So that's work order optimization. And then we also have filed a patent for a software called Digital Twin for solar power plants, wherein we recreate the entire solar power plant and we tell them exactly where the plant is not performing and how you can rectify it and improve your revenue and efficiency of the plant. And I would say that we were one of the lucky companies and teams to have actually worked on green hydrogen and ammonia when it first started in India. So we worked on microgrid concepts, energy management system with green hydrogen and ammonia, and we are also building digital twin for electrolyzers. We are building digital twin for battery energy storage systems, recreating how in the physical real world how it is behaving versus how it will be behaving in the digital aspect, and telling them the percentages, the performance, the degradations, and 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 different exposures to also multiple modules like something called plant accounting settlement system. It's basically a billing software, which is a must in GCC countries. So we had the opportunity to actually execute an order in Oman for a 125 megawatt plant, where Petroleum Development Oman was the off-taker. And there was an invoice generation system at the plant end. There was an invoice reconciliation system at the buyer's end, wherein the encrypted file goes and automatically invoice is generated and the bills are paid. So from end to end, from data picking till monitoring, control, and then also in generating invoice with power arbitrage and intelligent bidding is something which we have created on Smart Grid. So that's one of it which we have aimed, because none of the companies in the world have this entire feature together. And to get this, they are acquiring other companies to achieve this.
Right. So as I understand, there are a lot of operations to ensure that the operations are efficient. So which would mean that, the work should be optimized. There should be lesser human error. So, how do you integrate artificial intelligence, data analytics into your systems, into establishing smart grids?
Yeah. So for precisely answering that question, whatever we are doing over this is on entire SaaS based, that is a software as a service model, where it resides on the cloud. And once the data is aggregated from the field, these AI and ML technologies will be able to tell you how the device is performing in the historical basis and how it's going to perform. So your preventive, prescriptive maintenance also will come, predictive maintenance also will come, that when the device is going to fail and what do you need to actually to have in stock to ensure that even if it fails, you have a lesser downtime. So that increases your productivity and revenue.
Right. So, India's energy sector is also ridden with its own challenges. So, and you have a company called Smart Grid Analytics Limited. So, how do you address different challenges with this new platform? If you have to give an insight, what kind of different solutions are you providing under this company?
So as I mentioned earlier, we have multiple modular solutions, which actually works into a bucketing kind of system where you have data aggregation from the field. That's one solution which will pick up the data. Then the other addition is online SCADA. Instead of having SCADA on premises, you can have it online. So which actually reduces your cost of burden, your IT assets. And then we have CMS, central monitoring solution, where you have multiple plants. The multiple plants data is aggregated, and then it is shown in the single window with predictive and prescriptive analytics. And then that module talks to another module, CMMS, on the back end through APIs, where any downtime of an inverter, that is a revenue generating equipment, goes down, automatically a work order is created. And then the CMS will also have digital twin, which will actually give you a precise forecast. So since we do a digital twin of the entire plant, they get a better forecast in terms of committing to the grid authority, saying, I will be able to generate this much amount of power tomorrow. And based on that, we are also working on digital twin for electrolyzer and hydrogen, wherein we can tell how much capacity of hydrogen will you be able to produce tomorrow based on the weather forecast of tomorrow. So precisely, you know how many cylinders can be produced, how many cylinders can be sold, and at what price. And also we are working, we have another module called intelligent bidding, wherein you can connect with the online trading or round the clock power, where in specific times, if you have to dispatch power, you get a per unit higher revenue compared to the normal generation hours. So
Right.
these are the technologies which we are working on, and that's the entire USP, I would say.
Right.
None of them have all this together.
Right, sir. So I would like to understand what is the presence of smart grid analytics in India. So, I mean, how many clients do you have? Maybe the number of states you're present in.
We are present in almost all the states in India,
Mhm.
because solar and renewable are spread across solar and wind are spread across every state.
Right.
We have almost more than 15 clients currently in less than a year's time. In Armax, we have more than 50 plus clients. We have done almost 16 gigawatt of installations in India and abroad in Armax.
Right. Right.
And Smart Grid, we have done around 4 gigawatt of installations.
Hmm.
So all our large blue client Intel customers who are NSE listed,
Mhm.
who are stock exchange listed, who are having multiple plants, and we are also doing world's largest power plant work order digitization in Dubai.
Okay.
Dubai, yeah. So
Right.
yes,
So, sir, that's all the questions I have. Thank you so much for taking out time and sharing so many insights, because this is a topic which is not as much talked about as maybe solar energy or wind energy. Head to our website tpci.in. Thank you so much, everyone. Thank you, sir.